Hello everyone. In this presentation we are going to see how to use the 8051 microcontroller, and what you see here in this table, what you see here in this board is, you can see an LED is coming from a ball is coming from top to bottom, and then ball is going back from bottom to top. It looks like this, but it is something like switching on an appliances for a period of time and switching off an appliance for a period of time. So sequentially it is switched on and off in sequence up to 8 devices, and then again in the reverse order it is switching on and switching off, as you know here very well. So the LSB is switched on first, then switched off, then finally MSB is switched on and switched off, and in the reverse order MSB is switched on and switched off, and then sequentially it switches on and off and goes to the LSB. This repeats continuously, which resembles like an ball is moving here and there from the top to bottom as well as bottom to top. So top to bottom can be used for left indication, bottom to top LED flow can be used for right indicator. When you do keyboard interfacing, this can be done. When I press this key, so it is moving from the top to bottom. When I press this key, it is moving from bottom to top, something like that we can relate. It's very interesting. So this experiment makes us to understand I can switch on the individual appliances as per my wish with some particular delay, and that can be done through port 0, sending out the data through port 0. And if you look at the code, you can understand much better, as you see here. So in this code, as usual, the code initializes with hash include reg51 and a small delay. After that you can see, so port 0 is given 00, then 80, then 40, then 20, then 10. So 4 LEDs will switch on in sequence. Then 8421. Another 4 LEDs are switched on and switched off in sequence. After that we are making 00, and then in the reverse order from 00, so 1 2, 1 2, then 4, then 8, and then 10, 20, 40, 80. So this is repeated in sequence, is something like ball is going out from the top to bottom and then bottom to top. So when you decrease the delay, you see, say for example, instead of 12,000, if you make it as 6,000, let us see, if you reduce the delay from 12,000 to 6,000, what will happen? You see, I am changing the delay from 12,000 to 6,000. So it's very interesting. I can copy this and then I can paste, whichever is convenient. Let me do this, copying and pasting. Stop. So 12,000 delay is changed to 6,000. So that means the delay is reduced, so the speed will increase. Let us see. Now you can see, if you see this, slowly it is coming from top to bottom. So the speed will increase because the delay has reduced to 12,000 to 6,000. So we are compiling and building the code. So after compiling and building the code, we are going to the Novoton for downloading the hexadecimal file into the target machine. So after loading this hexadecimal file, and then we are downloading this. After pressing update chip, you have to press the reset button. When you press the reset button, it has to erase and download. So sometimes file like this, when you get file, don't worry. So once again you have to click upload. So once again you have to press the reset button. So you will get the pass. So once pass, when you click enter, you can able to see the top down movement and the bottom up movement is little bit faster because of the delay has changed from 12,000 to 6,000. This is another way of experimenting the LED interface by sending out the data through port 0, which makes a pattern like this. It is something like ball which is moving up and down within the court, something like that. It's very interesting. Thank you.